say let's say you're taking input from somewhere, reading from a file or whatever, and you need to check before moving on whether A, B, C, D, and E, whether they are ints or floats. Otherwise, if any of them is not int or float, then you're not processing, then you're not moving on, and you're going to check the input arguments again and so on. These kind of functions are there because whenever you call certain whenever you want to do processing on data, sometimes it is required to check the type of the data, whether the data is supplied in a way that you were expecting and so on. So let's have this function checkargs. I'm not writing document string here. I guess I've told you enough to write document string again and again. So let's say if is instance A, if is instance int float, if that is true, and is in, let's just have 3 variables just to focus on. If is instance A, then B, and is instance C, if all of them are integers or floats, then do something. Then let's say print A plus B plus C maybe, or A plus B plus C raised to the power 2. Just print their square, let's say. Else, or if they are all integers or floats, then do some interesting task here, some task. Otherwise, you can say, okay, print error. The input arguments are not of the expected types. Fine, you have this function. Let's call this function. The function was check args, so let's check args. Check args, let's say 3, 4, 5. So now you have all of them are great. Let's say you have check args, and you call this check args on, let's say 3, 4, but this 5 is a string, let's say G. Now you'll be having an error. The input arguments are not of the expected types. One of them or more of them or whatever. Yeah. One more thing. This function is expecting 3 arguments. If you call this function by less than 3 or more than 3 arguments, you'll be getting an error. For example, 3, 4. Although this function is accepting 3 arguments, you're calling it with just 2, you're getting an error because you have not specified all the arguments that the function is requiring. Although the arguments that you have supplied, they are of the type that it is expecting, but you have not supplied the number of arguments that the function is expecting. Similarly, if you call this function by more than 3 arguments, although it requires 3 arguments, you again will get an error because it is expecting 3 arguments and you have not supplied 3 arguments. Later on later on we will see how to write a function that accepts variable number of arguments. We will see that, but right now in this particular way, if you write the function if you define the function in this particular way, you have to define the arguments, the number of whatever the number of arguments it is expecting, you have to supply exactly as many, otherwise you are getting an error. Okay, so that's about the multiple arguments. Okay, what next? Well, next time, in the next video, we will see that what's the importance of order of these input arguments. What will happen if I just swap message 2 and message 1? Will that change the behavior, or is there any order? The first variable, the second variable, third variable, is there any ordering inside the input arguments? Yeah, there is. So let's see in the next video. In the last video, we saw how can we how can we define a function with more than one input arguments. It is important to know that the order of the input argument is really, really important. So whatever argument at the call time, for example, if you call this particular function, the name of the function is f, that's not a great name. You should have a name that is descriptive, but I recommend to write good names. Let's say this is f, that's a function, and the very first variable is c2, the second variable is c1, the third variable is c3. Now you, let's say, call this function like this, let's say 2, 4, and 9. What will happen is this 2 will be copied in c2, this 4 will be copied in this c1, and this 9 will be copied in this c3. Now c2 has a value 2, c1 has a value 4, and c3 has a value 9. If you change the symbols or the variables order here, whatever order you have written there, the first value that is passed at the call time will be passed to the first variable, whatever the name of the first variable is. The second value at the call time is copied in the second symbol, whatever the name of the symbol is. So this ordering is really, really important. One way to one workaround for this is at the call time, you actually define the variable names and their values. For example, you call f and you say, okay, c1 has this particular value, but this way you need to know that there is the symbol name in definition is exactly c1. So c1 has this value, c2 has this value, c3 has this value. Once you, at the call time, if you have defined your variable names along with their values, then you are order free. Now you change whatever, if for example you call this way, c2 is b, c1 is a. Now no matter in what order you have called these, this c1 is going to be copied in c1, this c2 is going to be copied in c2, and this c3 is going to be copied in c3. For the functions that has many more arguments, it is good to call the function in this particular way if there is a chance that calling a function in a different order may become confusing and stuff like so. This actually gives you more grip on this ordering issue. If you're happy with, if you're very smart and you say, okay, I will always supply in a particular order, I will always read the document string first and then I will call that function, that's okay. Otherwise, this is also a feature that is available. At the call time, you assign the values of the functions that are there at the definition time. And now, no matter in what order you are calling that function, C1 occurs at third position, C2 occurs at first position, the relative values will be copied according to their names. So, and that's a good feature. That's a very good feature. Let's see, for example, a running example of this in Python, in Jupyter Notebook. Okay, define, let's say function f. Let's say it receives a, b, and c. Let's say 3 values. And let's say it prints a is, let's say it's print a is a, and you say okay, b is b, and then it prints okay, c is whatever the value of c is, that's a c. Okay, now let's call this function f with, let's say, 2, 3, and game. So we will say, okay, A is 2, B is 3, C is game. Fine, great. Now this 2 will be copied in A no matter what. If we change this calling order, for example, if we change this order, we just move to this particular order. We just say, okay, this is 3, this is game, this is 2. If we call like so, now 3 will be copied in A, game will be copied in B, and 2 will be copied in C. And that, if that is the behavior you want, then you are good to go. Otherwise, it is handy to call the function in the following way to just fix, okay, A is 2, fine. B is 3, and C is, let's say, game. If you want these numbers. Now, if you call the function like so, that will happen. Now, if you change the order, no matter what order at the calling time you come up with, it will stay the same. For example, you go and say, okay, C is at the first position, and A is at the second position, let's say 2, and B is at the third position, 3, the output will stay the same. And that's a beautiful thing. So that's one way of handling with the order. If you think at call time it is important to define the variable names, but it has one problem, that you need to know exact variable names. If the variable name is C1 there, you need to know what it's C1. You need not to, I mean, the C1 matches with C, it must match with C1. C2 must match with C2, and so on. So you need to know these names. Okay, great. In the upcoming videos, more features of functions are going to be discussed. So stay with us. Hope to see you in the next video. So in the last video, we saw the ordering of input arguments in a function. And we saw a fix to it. I mean, if there is a chance that you may miss a proper order, there is a way to fix that. We saw that in the last video. But here we have another thing to discuss. This x variable, x input argument, this is the variable that is defined inside a function. Although the value it receives is copied from somewhere else, but it is defined inside the function. That is also the function variable, or the variable that is in the scope of the function, inside the function, in the body of the function, something like so. It may be handy, for example, let's say you compute something, you do some processing on your inputs, and whatever the result is, you save that result in another variable. And let's say now you need the value of this variable to do some further process. Let's say what you do is, let's say at the call time, let's say this is the function. Let's say this is the complete function, and let's say A is equal to 12 and B is equal to, let's say, 7. And let's say you call the function add A, B. Now the value of A will be copied in X, the value of B will be copied in Y, okay? And now you need the sum of A and B to be received here in a variable. You want a variable in which the result should be saved. For example, let's say the variable is D, let's say. And then you want to do some more processing on D, let's say D double star 5 mod 3, and maybe you need to apply an if condition on that. If that equals to 0, then do some stuff otherwise. So let's say you need this variable out. What will happen is this C variable is not accessible outside this function, and the reason is the C is defined inside the function. When the function body completes its execution, the C is lost. C is no more available. C is defined when the function call has been made, when the when you are executing this statement, C is defined and a memory location was created in a C, sometimes called the function space in the memory or process space that is created in memory. But once all the body of the function executes, all the functions that were inside the variable, they're lost. How can you receive this value? How can you receive the value inside C outside this function? So that is question in this slide. How can we do that? Further, this particular function can access all the variables that are not defined in this function, but that are available outside this function and are defined already. For example, let's say I have a function f, and the function is, let's say I have a function f, and so if this function is defined like so, f, let's say f is your function, and it is defined like def, and that's it. And here it prints, let's say, some variable, let's say a. Let's now this a variable is no longer in f, not even defined in f. But as long as this a variable is defined before calling f, for example, that's the cell where we are writing the code, and we say, okay, a is equal to 7, and then we just call this f. Because a was available before calling f, a is accessible here. So the functions, the variables that are available before the call, they are available inside the functions. But the variables that are defined inside the functions, they are not available outside. That's a problem. Further, if we define this a here, a is equal to 2, now this a is sometimes called the local variable, or the function variable, the variable that is local to the function. Now this a is defined inside the function, and all the accesses to a will access this value 2 rather than the 7. Consider the 7 has a separate location in memory, and this 2 has a separate location in memory. Both have names a, but this a will only be referred to when the function is executing. After the execution of the function completes, this is gone from the memory, and this will still be available. This 7 will still be available. So it is good to know. And by the way, if a was not defined here and you still called f, then either you will be getting an error, or this a might be a global variable or available in some package that you have already loaded or stuff like so. In that case, this a will be accessed if it's a global variable or accessible. So it is good to know the scope of the variables inside the function, because when you're calling them, what functions, if x is already defined, for example, if x is already defined like 34, and then this x is 34 as long as this x is not defined here. If x is defined here, this x actually is the local copy, and that will be accessed inside the function. Once the function is gone, again x will be 34. So it is good to know the local copies or the function space itself. But the problem here is how to access this variable, the value of this variable outside the function, because this is completely defined inside. How to access that? Well, there is a fix, and that fix is called the return statement. If you write the return statement, for example, you return this value, so x plus y. You might have saved these values. You might have saved these values, for example, c equals x plus y. That's okay. And then you say, okay, return c. What will happen is wherever you have called this function d equals add, let's say 2, 3. Now this value c, which in this particular case is 5, that value will be returned in d. And all the properties of this variables are returned in D. So just like this C is copied in D, and this is available further, whatever you want to do with this D. Okay, so yeah, so return statement is there. So in the next video, we will actually code this in Jupyter Notebook and see the return statement running, and we will see the scope of the variables and all that in Jupyter Notebook. So hope to see you in the next video. In the last video, we saw scope of a variable, particularly if a variable is defined inside a function is it accessible outside the function, and if a variable is defined outside the function, is it accessible inside the function, and vice versa, and so on. So we discussed those kind of things, which is sometimes called scope of a variable. And further we discussed what if we want a value of the function that is computed, value of some variable or some result that is computed inside a function. What if we want that to be accessed outside the function? So we discussed that in detail in the last video. So let's see all those concepts in a running form in Jupyter Notebook. So let's see how it works. So first of all, let's define a variable. Let's define a function. Let's say define, let's say my add, and let's say it receives two arguments. Let's say a and b, and then let's say c is a plus b. Let's say that's c, or c value. Let's say c value or some value, whatever you want to call that value, some value. That's it. Let's say we did that. Now we want to access that some value from outside the function. Print some value. By the way, let's first call this function. Let's say my add for values, let's say 2, 3. So 2 will be copied in A, 3 will be copied in B. So then let's try to access this value, some value. It will throw an error, and the reason is this variable some value is not accessible outside this function. What if we want to access, because this is defined inside the function, what if we want to access this, what if we want to compute some result and then use that result outside the function? So the way out, as discussed in the last video, is return statement, return value. And now if we call that again, if we call that again, now we haven't actually registered. By the way, remember this, that's a common error. I got in that error many times. If you change the implementation of the function, you have to rerun that cell. You have to register the updated copy of the function to the Python. Otherwise you will be getting errors, probably. Yeah. What's the problem here now? Print some value. The some value is still not accessible, because some value is not accessible. It is a variable defined inside the function. It is the scope of this variable is just the body of the function. So let's receive this output in a variable d, and then let's just print d, and d is 5. Great. So one more thing, let's say we define a variable here, a variable outside the function. Let's say that's a variable name. That's a very lengthy name, but let's say that's a name. Variable outside the function. Let's say its value is 3. And then let's define another function somewhere. Let's define another function down somewhere. Let's say define f maybe g, and it receives nothing, but it prints this, let's say variable outside the function, and that's it. Let's say that's a function. Now when we call this function, this variable outside the function, that is accessible inside the function. And if this function, and if this variable, it is not defined inside here, and if this is defined somewhere else and it is global or accessible, it will still be accessible. However, if we define a function with the same name, let's say variable outside the function, let's say 5. Now this function will print 5 because that's the local variable, in the function. Now this will be accessed in this print statement. Let's see. Now the result will be 5, but if you print the variable outside, now the value will be 3, because this variable, this particular variable that was inside the function, it got destroyed when the function finishes, and this is available again. So yeah, so you need to know, by the way, it's a good practice whenever you want to access particular variable inside, it is a good practice to pass that variable as input argument to minimize the confusions, because this can create a lot of confusions. So it's a good practice, although the feature is available and sometimes useful as well, but it is always recommended to pass the values as input arguments, that whatever you want to access inside the function. Okay, so one more thing, this function g is returning nothing. For example, it is not returning anything, it is just printing, let's say, something. Let's say it is not printing anything. Let's say this is a comment. Let's say it is not printing anything. So this, and then we call this, and that's it. So it has no return value. By the way, in Python, even if a function does not return anything, it still returns a value which is called none, which you can see here. So in Python, a function always returns a value. If you write a return statement explicitly, it returns that. If you do not write return statement, when the function body finishes, it automatically returns none. Let's see the type of this output. What is the type of this output? What is the type of this none? What kind of data type is this? Let's see. It's a none type. I mean, that's a type in Python. So it returns a none type output. How fancy. Wow. One more thing, the return statement is not only used to return a particular value. If you, for example, in a particular function, let me write a function here. Let's say def, let's say the function is h, and then inside that function you do something, let's say print a, let's say then you define a variable, let's say a equals 2, 3, let's say, then b equals, let's say 5, and then you add those values a and b, and then you do some other stuff, let's say print something, and then you just write a return statement without any output argument. I mean, it is not returning anything. You can still I mean, continue writing the function body more and more, but what happens is, whenever the first return will be encountered, the function returns from there. So the effective body of the function is just that. The function returns right from there. If you return a particular value, for example C, you can receive that value outside the function. If you do not return anything, just type a return statement. That means exit the function right away. It works like the break statement in loop. Remember the break statement? It resembles to the break statement. Return means just exit the function right away, no problem. And by the way, when return is called, the default return value that is returned is none type, if the return is called without an argument here. So for example, let's run this function. Let's see, and let's call that function h. Yeah. So it prints a, then it prints something, and then it returns. And it returns, for example, it returns nothing but a none. Yeah. It returns a none. And if you return C, for example, C, then it returns a C, value of C, which is 8. And this time, the return value is no longer none type. It is probably an integer type. Let's see. Yeah. Here. So it's integer type. Make sense? Yeah. So return statement has two purposes. One, you can return a value. Two, you can return, you can just return the control. You can just exit the function like the break and loops. Just one more thing. a return statement can return multiple values. For example, let's say we have defined a function, let's say j, let's say g we already have defined, we can redefine it, but let's say r is our function, and we just have a equals 5, b equals 7, and d equals, let's say, something. And then we just return them a, b, and d. So return statement can return multiple values in a sequence. Now if you receive those values, let's say x, y, and z equals r, so a will be copied in, a is the first return value, it will be returned in x, it will be copied in x, b will be copied in y, and d will be copied in z, just as a sequence as you keep the sequence in the return statement. If you change the sequence in the return statement accordingly, so whatever the first value here is the first value here, whatever the second value here is the second value here, and so on. So let's run this and just print all these things, x, y, and z. So yeah, 5, 7, and something. So this return statement is really powerful. I mean, it can return multiple. Not all the languages actually, they have feature to return multiple values, but Python does have feature to return more than one values, and more than one values of any type. A can have different type, B can have different type, D can have different type, and so on. So that's about the return statement, as well as the variable scope, and whether you can access a variable that is outside the function or inside the function, and so on, and all that kind of things. In the next video, we'll talk about what if we want to access arbitrary number of input arguments. I mean, we do not know how many arguments will be there inside, but no matter how many arguments a particular user is giving, let's say we want to write an add function, just to give you an example. Let's say we want to write an add function. Let's say define add, let's say add2, another function add2, and let's say it receives an arbitrary number of arguments, d in, I don't know how many, and it has some implementation. Then anybody who want to call this add2, if that person gives two arguments, then just 2 should be added. If the person gives 3 arguments, then 3 should be added. I mean, the person can give arbitrary number of arguments. How can we handle that? Because the caller, this is the call, the caller can give 5 arguments, 6 arguments, 7 arguments, and earlier we saw in the definition the total number of variables. When we specify, we have to pass those many arguments for sure. If a single argument is missing, or a single argument is just more than the specified number of variables, we will be getting an error. But how can we handle this situation where we have an arbitrary or variable number of input arguments? How can we handle that? So to answer this, or to get how can we do that, see our next video. It's coming. Yeah. So in the last video, we were talking about how can we handle arbitrary number of input arguments. For example, let's say we want to write an add function that should be able to add any number of, let's say, integer or floating point numbers that are passed in. Remember last time we discussed in an earlier video that when you are defining a function, the total number of variables that you are defining, you have to pass exactly those many input arguments, otherwise you are getting an error. But this may be required sometime, that we want to add a universal kind of add function that has capacity to receive any number of arguments, but no matter how many arguments it receives, it just add them all and return the result. Such a function, if available, will be very, very helpful, because sometimes we might be calling that function by just 2 arguments. Sometimes we might be calling that function with, let's say, 3 arguments, and sometimes more arguments or less arguments, and so on. How can we have this kind of feature available, but the implementation is just one-time implementation? Well, Python have a very, very easy way of handling this arbitrary or variable number of inputs. And the way you do that is when you are defining a function, you just write a star and then just print, let's say, one variable name, let's say args. And then after that, this args will act like a list. And I mean, it will be having a lot of properties, args. This args has a property, this acts like a list. So all the arguments that you will send in will be received like you're receiving those in one list. And all the elements which are the arguments in the list, they are accessed by different indices. We will see lists in detail later on, but right now just think it is a collection, all the collection, it is received by indices. For example, the args, the very first element is indexed by 0. It is at the 0th location. At the 0th location, there is a 3. At the first location, for example, the location index number 1, which is actually the second look, the 4 will be copied at this, and so on. Now, no matter how many arguments you pass, a list will be of that size. And there is a function length, len, that is handy to just check how many arguments are there. Now, if you pass 2 arguments, the length of the args will be 2. If you have passed 3 arguments, the length of the args will be 3, and so on. No matter how many arguments you pass, this args, it will receive all them in one by one, and all the elements in that args will be indexed by 0, 1, 2, starting from 0 until the length of the args. So see, for example, here, the sum equals 0. Let's say we want to add all these. For I in range, and inside range, we just give the length of args. For this example, 1, 2, 3, 4, 5. The length of arg is 5. So I will start from 0 till 4, because 5 is not included. So the very first time I will be 0, and args in subscript 0 is actually the value of the first variable, which is 3. So 3 is added to 0. Then next time I will be 1, and at the position 1, 4 is located. So 3 plus equals 4, which means 3 equals 3 plus 4. A sum equals whatever the previous value of the sum plus 4. Then next time the value of I will be 4. You know how this loop works. We discussed the loops in detail. And as you move on, you actually explore all these numbers, and this variable sum actually contains the sum of all the variables. Now you can return this sum, and this particular function acts like a universal kind of function that receives arbitrary number of arguments. How cool is that? Let's see in Jupyter Notebook to get more convinced how it works. So let's say we have define, let's say we have any function, my add, let's say that's function, my add powerful, let's say, yeah, universal or universal, my add universal, and it receives star, whatever the variable name is. You can write the name args, or you can write any other variable name. This is just a name of a variable. Okay, then let's say we have s equals 0, which is sum. Then we just apply a loop. I guess you know the loops. We have lengthy discussion on loops. In range, length, that's a built-in function, length, args. Okay, then what should we do? S plus equals args I, which means access all the elements one by one. And this is again the same as s is equal to s plus args I. Either way you write this way or that way, both ways are fine. Then when the loop finishes, s contains the sum, just return it, and you are done. Wow. Now let's call this add function my add universal, and let's call this function as 2, 4, and 5 for these, and let's just print the result. Okay, the result is 11. Wow, because 2 plus 4 plus 5 is 11. Now let's call this function for, let's say, for let's say 5 arguments. It works. It adds all these 5 numbers. Wow, that is great. I mean, now we can add any we have one function. We need not to write a function for 2 arguments, and then another function for 3 arguments, then another function for 4 arguments, and so on. Depending upon the number of arguments, we need not to write separate functions. We have just one function working in all scenarios. Wow. So yeah, that's doable. I've done in front of you, no problem. Yeah, Python allows this. Yeah. In the next video, we are going to see how can we actually handle the same kind of scenario, but we want to handle the sequence of the input variables in a very controlled way. Remember in some of the previous, in this order of input arguments, remember that we received 3 arguments and we passed the 3 arguments in a very controlled way. And then whatever these are, we don't care. Whatever the order here, we don't care. What if we want to fix the input, or we want to become more careful for input argument orderings, but then we also want the arbitrary number of arguments? How can we do that? Yeah, wait for the next video and I will show you how can you do that. In the last video, I promised you that I will show you how can you achieve the ordering of the input variables but still having the arbitrary number of them. Remember, this looks like much familiar to you. That's a call that can be made to a function, and remember the function definition in some previous slide was like C1, C2, and C3 maybe, and then something. What if we want an arbitrary number of arguments to be passed, but we want their controlled? For example, let's say this particular variable symbol name that acts as a key, that's a variable name, and that's the value. So let me call the variable name as a key, and this is the value that is copied in the variable. That's another key, that's a value. That's another key, that's a value, and so on. What if we have a lot of key value pairs? What if we have a lot of them? And we also want to check which value is of what key. Let's say we want to specify those, but we want to specify an arbitrary number of them. Let's say here, for example, there are only 3. Let's say we want to pass 5 of them, 6 of them, and then we want our function to perform accordingly, no matter how many input arguments it received. Yeah, and maybe inside the function we may have applied a check that if the key value is C1, then do this processing. If the key value is C2, then do that kind of processing, and so on. Let's say based on different variable symbol names, we want to process the value differently. How can we achieve that and still having the need that these number of variables can be in a variable length? They can be an arbitrary number of those. So Python gives you again a very, very simple way. Rather than writing a single star, you write a double star, and then you receive in whatever variable name. And now in this double star means you are receiving a key value pair list. It's a list of key value pairs. We will see that resembles to a data structure in Python called dictionary. We will see dictionary later on in detail, but right now just consider that this input argument, this input variable C, it contains a list of key values pairs. And then you can just iterate over this C. You can just apply a for loop to check the contents of this. Remember, we have actually done that kind of thing in the portion of loops. Yeah, here. Remember, that was a key and that was a value, that was a key, that was a value, and we did that thing. We could explore we were able to explore the dictionary just using for loop. Yeah, it's the same thing here. It's not exactly, but you can think of that. That's exactly the same thing. So you can explore that C looks like a dictionary now. This is key, this is value, this is key, this is value, this is key, this is value. This X points to the first key, then C of X points to the value based on the key X, and then X points to the second key, then the second value, and so on. That is very simple procedure. You are just printing all the dictionary, but you are printing all the variable names and their values, but you can do very complicated processing if you want to. Let's go to our friend Jupyter Notebook to just get convinced that this indeed works. Let's see. So let's define a function first. So def, let's the function name is print all variables and values. So that might be a function name. Wow, that's lengthy one, but descriptive one. Maybe we can make it more descriptive. Print all variable names and values. Wow, that's more descriptive, I guess. So it receives, let's say, double star any variable. Let's say the variable name is, again, let's say args or anything, whatever you want. Then what we do is for x in args, just print let's say variable name is, just print x, and then okay, just print x, and then just continue, and value is args of x. So let's say you did this. So the variable name is this and the value is this. Okay, and you want to do this for all the variable and value pairs that you send at the call time. So now let's call this print all variable names and values, and let's call this, let's say the first variable name, let's say, is a, and its value is 3. The second variable name is, let's say, b, its value is capital B. Let's say the third variable name is c, its value is ccc, and let's say the fourth variable name, I mean, you can define an arbitrary number of arguments here. Wow, that's amazing. Let's say the fourth variable name is y, its value is 6.7, and further notice you can pass variable and value, all have different types, I mean different number of them, and much more. Yeah, you can do that. So let's call this function by just having 4 variables and their values. Let's see what we got. So variable name is a and the value is 3. Variable name is b and the value is b. Variable name is c and the value is ccc. Variable name is y and value is 6.7. You can give an arbitrary lengthy list here if you want, and Python just allows you to do that, and it allows you to do that in a very, very simple way. That's amazing. That's amazing. I mean, that's what a high-level language, or really a powerful language, should have a feature. So Python does have this feature. I'm really amazed. I really astonish Python. By the way, I'm not saying the other languages don't have this. Several languages actually support this kind of feature, but Python supports it in a very easy way. It's very easy to do that. I mean, it's not a rocket science. Yeah. Okay, so now we have handled an arbitrary number of arguments, even with ordering is really controlled. We have 1 or 2 more videos on functions just to explain a bit more. Then we will practice on Jupyter Notebook. We will play with these functions a lot, and we will be calling one function inside the other function and so on. We will be having one better program, just program a new Jupyter Notebook just to get comfortable with these functions. But before that, let's have 1 or 2 more things to discuss about the functions. Yeah, let's see. So hope to see you in the next video. Okay, I really want to talk about these default values for a function as well, because that's important and mostly needed. The default value is a value of the input variable that you assign while you are defining a function. And if the value is, for example, if you call this f with, let's say, the input value 3, then 3 will be copied in the sum and the print will be 3. But if you call this function without the input, then this value acts as if you have passed this. So this is the default value. If you do not supply the value, this is the value that is going to operate. And by the way, you can have multiple variables with default values, some variables with default values defined, some variables with default values not defined, and so on. So you can have this. One care must be taken here that the default value, when you actually define the function and you compile this function, actually you run the cell shift enter in Jupyter Notebook, at that very time this variable is assigned this value at that particular time. It is not assigned at the call time. So sum equals to 0 is already there when you actually press shift enter for a cell that contains this code. Now later on, if you pass a value, that value will be overwritten on sum. If you don't pass the value, the 0 will go on. It looks like very easy. But one care that I want to mention here that I haven't mentioned earlier. In Python, there are certain variables that are referenced rather than copied. I will discuss the referencing and the copying in detail in data structures, but let me just tell you one example. Let's say you defined a list, let's say 1, 2, and 3. And then what you do, you copy this list into another variable, let's say L2. What will happen is in the memory, this list in a particular way, this is not the exact view of the memory, I'm just showing you. Let's say this is the particular memory layout for which this L is pointing to. This L is labeled for that. L2 is also labeled for that, which means actually in memory, this is not the copy of the structure that is made. I mean, this is not like in variables, for example, if A is equal to 3 and B is equal to A will be a position in memory and B will be a separate position in memory. That is what a view of the memory in ordinary variables are. But there are certain variables in memory just for memory efficient and code efficiency and time. People have designed these data structures in a way that when you copy them, when you just assign a variable to another variable, the memory view doesn't change. It's another name for the same memory location. So what happens is if you change any value in, let's say L2, at the zeroth index, let's say you change that by -9, because it is the same view in memory that changes, -9. And now if you print the elements of L rather than L2, you will get the changed value, you will see the changed value, and that happens. Now, why that is important in terms of these default values here for the function? The reason is if you are accepting a list, let's say the default is a list, and you're accepting a list and you are also defining some default value for the list, if that's your definition, let's say, then this default value is assigned at the very first time, and this L is really a local variable inside the memory. Now, once this cell is run, not the call time, at the what called the compile time, when the cell is run, this L is assigned this, and that just happens once. Now, if you call this list with some other list, let's say L2, let's say 2, 3, and 4, then if you call this L2 will go there, it will be copied in L, and everything is fine. But don't then expect the contents of L2 to stay in L, because L is this default values, they are assigned just once and they stay as it is every time you call the function. They don't change. They are not assigned at the call time, they are assigned at the compile time, and they stay fixed. So that care must be taken. I will show you that particular example in Jupyter Notebook shortly. This might be confusing right now because we have not seen lists in detail, but I just want to make this point. I just want to mention this because that's important difference. With ordinary variables, default value is just like a value, and if you don't supply a value, the default value just works. But with the variable that are reference type variables, you may expect something else. and the Python function behaves maybe differently, and that's because these default values, they are assigned at compile time. They are not, or compile time, actually this is not a compiled language. I should not use the word compiled again and again. Just think, when we define this function and we run the cell at that particular time, the default value is assigned, and the default value never changes. It stays fixed. Yeah, so, and I will show you that example. Why don't we move to Jupyter Notebook and see that example? Yeah, so, or why don't we do that in the next video? What do you think? This video? Okay, same video. Okay, let's go to Jupyter Notebook and see the default values. For example, let's see, let's say we have define a function, let's say gg, and the default value s is equal to 4. Let's say that's a default value, and we want to print, let's say, s if available from the call time. If not available, then 4 will be printed. Now we print, right now we are going to print, we are going to press shift enter. At that time, s is assigned to 4. S has now value 4. It is assigned there. Now we call gg, let's say, and we call gg without input arguments. Now the 4 will be printed. If we call this gg with some input argument, let's say 56, now the 56 will be printed, no problem, everything is fine. Let's see about the lists. For example, let's say the list is, let's say 1, 2, 3, that's a list, and then L2 is simply, let's say L2 is L. Then what we do is we change the contents of L2. Let's say we change the very first value in L2 and we place that value as -9, and then we print L. Now you might be expecting that L is a different thing, L2 is a different thing. Because L and L2, they both are pointing to the same memory, the content through L2 actually changes the memory view, and L also changes, and that gives the result -9 in L. Well, the behavior that I want to show you is different in the default values when we talk about. For example, let's say we define a function ff, and it accepts